Hey, what's up, my dear students? It's Naresh Babu. Welcome back to Physics class. Students, in this session, I'm going to discuss about oscillations in class 11. Let us start the game. Look at here. Oscillations. Yeah. See, in our daily life, you might have seen many types of motions like linear motion, circular motion. Then what about oscillatory motions? What about oscillatory motion? Example, see, if you go to park, in park you might have seen motion of swing. See, here this kid is playing on swing. So if you observe here, it is the example for oscillation, oscillatory motion. So motion of swing and motion of seesaw. See here, these two children playing on seesaw. So this is also example for motion of oscillation and motion of swing. Okay, motion of swing, seesaw, these are examples for oscillatory motion. Motion of stringed instruments. Motion of stringed instruments means motion of stringed instruments. Example, you can take guitar, violin, veena. Veena means like sitara, etc. So these are examples for motion of oscillations. That means oscillatory motion. Okay. So what is oscillatory motion here? Now we will discuss about oscillatory motion. Now we will discuss about oscillatory motion. What is oscillatory motion? Oscillatory motion. To and fro motion of a body about a fixed point is called oscillatory motion. Already I told you example about motion of swing and motion of seesaw. Okay, so here to and fro motion of an object about a fixed point. Example, motion of pendulum. Motion of pendulum. Motion of pendulum, if you observe, means, see, it is a fixed point. About this fixed point, pendulum makes oscillations here. Okay, like that. If you observe a swing, motion of swing, so here swing also about a fixed point. See, about these two fixed points, it will make oscillations here. Okay, so here motion of an object about a fixed point. Which type of motion here? To and fro motion. That means to and fro motion of a object. To and fro motion of an object about a fixed point is called oscillatory motion. Okay. So what is oscillatory motion? To and fro. To and fro. To and fro means like to address, from address. Okay. So here to and fro motion of a body. To and fro motion of a body about a fixed point. About a fixed point. About a fixed point is called oscillatory motion. Is called oscillatory motion. Okay, example already I told you, that is motion of a swing, motion of a swing. Next, motion of a simple pendulum, motion of a pendulum, motion of a pendulum. Okay, so motion of seesaw, okay. So these are examples for motion, oscillatory motion. Next we will discuss about periodic motion. Periodic motion. See, what is periodic motion? Periodic motion means a motion which repeats in equal intervals of time. That is called periodic motion. What is that? A motion which repeats in equal intervals of time. In equal intervals of time. In equal intervals of time is called periodic motion. Periodic motion. Okay. What are the examples for periodic motion? That is revolution of Earth. I can also say revolution of planets around the sun. Next, rotation of Earth. Okay. These are examples for periodic motion. First one, that is revolution of planets around the sun. Otherwise, I will take revolution of Earth. Revolution of Earth around the sun. That means for one revolution, Earth takes how many days? That is 365 days. That is 1 year. That means here it repeats its motion in equal intervals of time. That is, for every 365 days, Earth repeats its motion. Okay, around sun. So that's why it is a periodic motion. And another one, rotation. Rotation of Earth. Rotation of Earth. See, for rotation of Earth, it will take how many hours? It will take 24 hours. So, rotation of Earth is example for periodic motion. Is every oscillatory motion is a periodic motion? Yeah, my dear students, every oscillatory motion is a periodic motion. But converse need not be true. Why? Here, oscillatory motion. For example, if you take motion of simple pendulum, here pendulum repeats its motion in equal intervals of time. So, every oscillatory motion is a periodic motion. But converse need not be true. Why? If you consider oscillatory motion, for example, motion of pendulum, okay, motion of simple pendulum. See, here pendulum takes equal intervals of time for its motion, for its oscillatory motion. So here motion of simple pendulum, if you consider, means here if you drag the pendulum and leaves, okay, it will take equal intervals of time for its motion. That means it continues its motion in every equal intervals of time. So you can consider motion of pendulum also a periodic function. That means every oscillatory motion is a periodic motion. Okay, so that means you can consider motion of a pendulum is also, that means motion of a pendulum is also example for periodic motion. Why? Because it is repeating its motion in equal intervals of time. So we can say every oscillatory motion is a periodic motion. But every periodic motion need not be an oscillatory motion. Why? Here, see, if you observe here, if you take any point P, at one point this pendulum has two directions. One is while moving towards left, okay, and again while moving towards right. So at one point this pendulum has two directions. Okay, that means it is retracing its path. Okay, in simple pendulum, that means in oscillatory motion, here the particle is retracing its path. Okay, but if you observe periodic motion, example motion of earth around the sun. Look at here, see here sun and earth is revolving around the sun. Okay, so here if you consider one point P, at this point earth has only one direction, that is towards left. That is, here if you observe means earth at given point it has only one direction, it is not retracing its path. But here in oscillatory motion, this pendulum retracing its path at a given point P. Okay, but it repeating its motion in equal intervals of time. So that's why here motion of a single pendulum, you can also say periodic motion. But here if you observe, earth is revolving around the sun. Okay, it is a periodic motion, it is repeating its motion in every equal intervals of time, but at given point it has only one direction, it is not retracing its path. Okay, that's why it is not a oscillatory motion, it is not an oscillatory motion. So my dear students, so every oscillatory motion is a periodic motion, but converse need not be true.